Hello, I am Dr. Srinivasa, Assistant Professor of Physics, working in IDSG Government College, Chikmagalur, belongs to Kuvempu University. This video is an extension of the first video to explain the different effect of cosmic rays, in which the syllabus is allotted by Kuvempu University for the III BSc VI Sem students. In this video, we will discuss altitude effect of cosmic rays, latitude effect of cosmic rays, east-west effect, and cosmic ray showers, and last, origin of cosmic rays. What is the altitude effect of the cosmic rays? The study of variation of cosmic ray intensity with altitude is known as altitude effect. The intensity of cosmic rays, which measured by measuring ionization produced by cosmic rays at different altitude, the variation of cosmic ray intensity with altitude is as shown in the figure. It is observed that the cosmic ray intensity rises slowly up to height of about 8 km, after which it rises sharply to about 19 to 24 km. At heights above the 24 km, the intensity starts decreasing. Maximum intensity is not at the top of the atmosphere but well below it. The reason is that at this height, the primary cosmic rays produce quite a good number of secondary particles due to interaction with the nuclei of atmospheric gases. Due to this, abundance of cosmic ray particles is more at this height. With decrease of altitude, the absorption increases and therefore intensity falls. As altitude decreases, the density of the atmospheric particles will increases. These higher density atmospheric particles increases the absorptions of the gamma rays. Therefore, intensity decreases on as height decreases. In the next slide, we will discuss about the east-west effect. It is found that the number of cosmic ray particles coming from west is greater than those coming from east. This is called east-west effect and is maximum at the equator. At the equator, the number of particles coming from west is 14% more than the particles coming from east. This reveals that the positively charged particle present in cosmic rays, because we already know that cosmic rays mainly consists of protons, that is positively charged particle. When positively charged particles moving in a magnetic field experience a force both in a direction perpendicular to the direction of the magnetic field and perpendicular to the direction of the motion. The charged particles approaching the Earth's atmosphere are deflected by the Earth's magnetic field in a direction perpendicular to the magnetic field and to the direction of their motion. According to the Fleming's left-hand rule, the positively charged particles are deflected towards east by Earth's magnetic field and thus appear to come from the west of the vertical. Thus, at any azimuth or position, more particles approach the Earth from the west than from the east. That can be explained using this diagram. This is the Earth and this is any galaxy or supernova explosion which are produces the cosmic rays, and this is the direction of the motion of the cosmic rays, and the direction of the magnetic field is perpendicular to the direction of the motion, and they experience force towards this direction. I mean, if we looking against the cosmic ray, direction of the cosmic rays, the positively charged particle are deflected towards the right, towards east, and appears to come from the west direction, from the left side. This is another diagram which clearly shows that the cosmic rays are moving in the negative y direction, and the magnetic field is into the plane of the paper, which is along the negative z direction. Therefore, the cosmic rays experience a force in the negative x direction, that is from west to east. This is the north magnetic pole. The opposite side is the south magnetic pole, and the magnetic pole is into the plane of the paper, and the direction of the motion of the charged particles is in the negative direction. So they experience the force in the negative x direction, that is from west to east. So this is the explanation about the east-west effect. That means the number of cosmic rays coming from west is greater than those coming from east. That is called east-west effect. So in this slide we will show about the cosmic ray showers. What is the cosmic ray showers? It is the name given to a grouping of cosmic ray particles that have been produced by some common causes. In order to explain the origin of cosmic ray showers, Rossi constructed an experimental arrangement with 3 coincidence counters in a triangular pattern, and that shielded by using a lead block. When the primary cosmic ray particles pass through the lead block, the number of cosmic ray particles coming from the lead block is more as compared to that of the incident, that is 1 or more particles. This can be observed by Rossi and inform the shower producing of cosmic rays. Rossi results were explained by H.J. Baba and Heater, and independently by Caston and Oppenheimer. They gave cascade theory of cosmic ray showers. So in this slide, how the cascade of cosmic ray showers are produced. When a detecting device is used to study cosmic ray intensities, it is observed that the intensity rises momentarily to several times its normal value, which indicates that sudden burst of radiation. This sudden burst of radiation gives rise to the cosmic ray showers. The cascade theory of cosmic ray shower shows that the shower production involves 2 processes. One is radiative collision or Bremsstrahlung, and the second one is pair production, that means production of electron-positron pair. What is radiative collision? A collision between charged particles in which part of the kinetic energy is radiated in the form of photons or electromagnetic waves is called radiative collision. Pair production means a photon of sufficient energy creating an electron-positron pair near a nucleus. According to Einstein's mass energy relation, the energy is converted into mass. A high energy electron or positron present in cosmic rays loses energy when it collides with atomic nuclei in the Earth's atmosphere. It is called radiative collision. The energy appears as high energy photon. The photon interacts with electric field of an atomic nucleus and is completely absorbed, resulting in the production of electron and positron pairs. The energy required for pair production is more than 1 MeV. The electron-positron pairs so produced have sufficient energy to produce more photons on interaction with the nuclei. These photons further capable of bringing about pair production. The result is the generation of large number of photons, electron-positrons having the common origin as shown in the figure. So this figure shows how the large number of cosmic rays are produced which are reaching the Earth's surface. This is the primary cosmic ray, mainly protons, electrons and other heavy particles having energy of 10 to the power of 15 electron volt at a height of about 35 kilometer. When these primary cosmic rays interact with the Earth's atmosphere, secondary cosmic rays are produced like pi plus, pi minus, protons and neutrons, neutral particles, etc. and gives rise to a photons. These photons interact with, gamma photons interact with the atomic nucleus, produced an electron-positron pair. These electron-positron pairs have sufficient energy and also they can produce photons, and further these photons gives rise to a further electron-positron pairs. Therefore, a large number of cosmic rays are produced in a short interval of time, gives rise to a millions or billions of cosmic rays which are entering the Earth's surface. So once again, this can be explained like this. The multiplication will continue until the initial energy becomes divided between the large number of pairs and the individual energies fall below the critical energy when photon emission and pair production can no longer occur. Only a small fraction of the particles usually comes down the ground when a primary cosmic ray produces many secondary particles. We call this an air shower. When many thousands, sometimes millions or even billions of particles arrive at ground level, perhaps on a mountain, this is called as an extensive air shower, as shown in the next slide. So this is another diagram to show how the electron-positron pair are produced and also photons are produced. Again, this photon is interact with the atomic nucleus, produced electron and positron pairs, and also photon and electron-positron pairs. So within a short interval of time, a large number of cosmic rays are produced. These cosmic rays which are entering on the surface of the earth and on the mountains, shown like this. In this slide, we will study about the origin of cosmic rays. This is also called Baba's theory. Several theories have been put forward regarding the origin of primary cosmic rays and the mechanism by which they acquire enormous energies. The cosmic rays are originated by Milky Way, the other nearby galaxies, and interstellar space. So this theory in the beginning explained by explosion theory. Lemaitre, Regener and others have suggested that once upon a time the whole mass of the universe was concentrated in a single nucleus. About 3 billion years ago, this universe exploded, forming the galaxies which are still running away from the Earth from each other. During this explosion, called Big Bang explosion, a fantastically great amount of radiation was formed. Protons and other nuclei were shot out in all directions with all energies and in sufficient numbers. The cosmic rays are simply the debris, the dust of the explosion. This view does not explain the presence of the heavy nuclei in primary cosmic rays. The source of heavy elements found in primary cosmic rays cannot be the stars of normal size and normal composition. These elements found in stars of larger size and extraordinary composition called supernovae, which lie beyond our galaxy. The high energy heavy particles are emitted by sudden, powerful and luminous stellar explosion called supernova, which takes place in big stars once in 250 to 350 years. Thus, big stars in interstellar space can be called as the main source of cosmic rays. It has been established that only a fraction of cosmic rays originated from Milky Way and nearby galaxies. So cosmic rays can also be originated from the sun also. According to it, at the times of solar activity, violent explosion occur and ionized gases outshoot from the sun. Thus, some of the protons in the sun acquire high energies and thrown into